So here we have we just have a simple sphere, and what we're gonna do first is we're gonna do something very simple. Is we're gonna say we have 3 colors here, so So what we're gonna do is we're gonna do a simple vertex color, which is very. No, it's yellow. It's not red on my screen. Actually, it looks more Russian than French. That was totally not prepared, but well. Okay. So what we're gonna do is we're gonna do the standard face color. So here we have simple shaders, so we have view projection. We have a pass-through geometry shader, so it just does nothing. It just takes the triangle and outputs the triangle, so it does pretty much nothing really interesting for the moment. And so the first thing we have here, we're gonna want to colorize this. So sometimes we want a bit of control, and we have 3 colors, so we want every part of each vertex to be 1 color. So what we're gonna do, we're gonna use the semantic which is called vertex ID. So it's provided to you by the pipeline, so you don't have to do anything with your geometry. It's just a counter basically. So it's this is vertex number 1, number 2, number 3, number 4, so it's just a simple counter which pipeline provides to you, and it's really useful because when you have things like buffers, you can access buffers from it. So for now we can't connect the buffer because it's not declared in the shader. So we're gonna add this buffer here. So it's structured buffer, and it's float 4 because it's a color, and you name it, well, whichever color buffer. So now you have your color buffer here, and you can connect it here. I'll just reorganize the desktop a bit. Okay, so you have here it's structured buffer float 4. So the advantage of buffers compared to model is you can use dynamic buffers a bit everywhere, so it's quite easy to share. You can use it's very easy to write into buffers in compute shader, so it's quite really easy to do generative and just reuse it in your shaders this way. So you can just use this vertex ID. And now we need to say, okay, our sphere has more than 3 vertices, as you can see, but we have only 3 colors. So if you try, for example, here, we're gonna get a color from our buffer. So it's float 4 color equals color buffer IV, and we say output.color equals color. And now you're gonna see quite a problem, obviously, because it's colors went only in quite a very few amounts. So only this vertex here got colored, only this vertex here got colored, and only this one got colored. So problem here is when you have this buffer here, what DX pipeline does is here you try at some point you try to access vertex number 7, but we have only 3 elements in our color buffer. So pipeline returns 0 by default. So if if you try to access something out of the dimension, then it returns 0 for you. And if you try to write into something out of range, it will say no operation because you're out of the range. So we need to do like the same way as sprites are handled. So we have two ways to do it. So we have this way which works in shader model 4. Sorry. So you just say color count, and here it's 3. So normally you would put count color here and color count, and you just do IV mod color count. So now you have now it will just do, it's the same way as it's handled, it's the same way it's handled as if it was a sprite, to be exact. So we just always make sure we never out of bound. So now that's the shader model 4 way. So we have to create a new pin, and well, it's always, that means one more pin, that means one count, that means 2 more links. That's a bit cumbersome. So now, since we can do it in shader 5 instead, so we're gonna do, so we need to declare 2 variables, so count, stride, and now we do color buffer get dimensions, count stride. I'll just explain it in 1 second. So now you can just do mod count instead, and you don't need the color count anymore. So that means you remove, like, you can get the buffer size inside the shader. So I'll just put it on top here. So like count is how many elements you have in your buffer, and stride is the size of each element. So in that case, count will return 3 and stride will return 16, because one float is 4 bytes, and we have 4 floats, so it's 4 bytes by 4 floats, so it's 16 bytes. So that means stride is 16. But we don't need the stride here, but we have to, like, the function call request, so we just have to declare it anyway. So normally, if the patch doesn't run, because here I've made sure it's on VS5 on PS5, so yeah, if this patch runs, you should be able to run all the workshop, by the way. That means your machine supports the proper feature level. So yeah, using buffers is really convenient way, because otherwise you would have to create your own geometry with your own vertex colors inside, which is quite complicated. So here you can just declare any geometry, and you can attach any attribute with buffer. You can just use dynamic buffer to patch it, or you can use compute shader to generate it. So it's like it's just more and more common to use structured buffer instead of pure geometry. So now what we're gonna do, like, it's not really interesting to have vertex color because it's very easy, but now we're gonna do something different. Is we want to say I want this attribute but per triangle instead. So I don't want this kind of blending. I want each triangle to be one color. So that's something which is not so, you can't do it in vertex shader because vertex are shared across. So that's when you start to need the geometry here. So what we're gonna do here, we're just gonna ignore the color, return 1 again. And now we're gonna take this part and we're gonna move it to, because when we arrive in geometry shader, we have a full primitive. So now we can modify this whole assembled primitive and transform it. So what I want to say is now I want to use this color buffer, but for each triangle. So now we use this color buffer. And now we need to know the primitive index. So we need to know which triangle number. And that's one of the features which is not so known. So here we uint sv.primitive ID. So like vertex ID is gonna say this is vertex number 1, vertex number 2, vertex number 3. Primitive ID in geometry shader will say it's triangle number 1, triangle number 2. It's a counter pair primitive. So if your primitive is a line, it's line number 1. If it's a triangle, it's triangle number 1. So it's like, you know, well, everyone knows what index buffer is. So like primitive ID, if you have an index buffer, it will say this is the first 3 indices, so it's triangle 0, triangle 1. So now here, instead of getting the color for each vertex, we're gonna use it for each triangle. And oops, and yeah, it's pi. Try to extend a little bit. Okay, so it's pi.sv.primitiveID. And now it's not IV anymore, it's pi. And now I still have this white triangle, this white sphere, which is normal because we need to. For the moment, we just have the vertex and pixel shader declared to the pipeline. So we need to, of course, okay, so now, okay, I'll just leave it this way so I think everyone can read. So yeah, the idea of using primitive ID is it opens quite some nice possibilities for doing custom materials. So for example, you could say, for this triangle I want smooth normal, for this triangle I want flat normals. So you can use buffers to have this extra layer of control per primitive instead of only per vertex. No, because when you on the vertex shader, the vertex shader doesn't know about your primitive. Like the primitive is at first stage you have the vertex shader which will take every vertex and process it. But vertex ID is a number, like it's for like I can do it this way. No, I can't do a point. Like if I put myself in wireframe. Like, yeah, that's, for example, here. That's one vertex, that's one vertex, that's one vertex, that's one vertex. So vertex ID is the index of this point. Like a vertex, you can consider it as just a point. It's just a... so until it reaches the geometry shader, it's just a position in space. And the geometry shader says, okay, we need to take these 3 points and form a triangle out of it. So until you reach the geometry shader, the pipeline has no idea about your primitive, basically. Okay, so we're gonna continue to the next example. Okay, everyone got it open? So we're gonna now I'm gonna show some other feature. Like with geometry shader, you have a lot of control about not only how you change your geometry, but also where you output your geometry. So we're gonna do a simple example. Like, let's say I have 3 viewports, which are in pixel space. And what I want to say, I have like two slots for picture, so just put whatever picture you want in there. It should be, anyway, assets. You should have a few here. So for now, we just have like a simple koala picture. Now we have 3 viewports here. And the idea is we want to say for each of these quads, we want to route them to this specific viewport. So if I attach we use this node which is called viewport array. Which is a new node from this release. So like before you had this viewport pin here. And I'm gonna explain a bit the internal of it. Like if you put like a spread of like viewport, you have 3 viewports. So what the pipeline, the renderer is gonna do is gonna say assign the first viewport, go through all the layer on draw, then go back, assign the second viewport, do it again, assign the third viewport, do it again. But it's not so useful because it's quite complicated. You don't really have good control over it. Like what I want to say is in my shader, I want to go to the first viewport, I want to go to the second viewport, and I want to do it directly in the shader because that means you can route with buffers. You have much more control over it. So we're gonna use this node which is called viewport array. You connect it to viewport as in between. So now this one works differently. So instead of saying bind a viewport, draw, bind a viewport, it says bind all the viewport at the same time. So all your viewports are set in the pipeline. So you're not limited to one viewport in the whole pipeline. You can have, I forgot the limit, but like I think it's 1000. So now, obviously, because our geometry shader does nothing, what we're gonna want to do is we're gonna want to say, okay, I want to assign one picture to one viewport, one picture to another viewport. So the first thing we need to add is we need to say, okay, now I need the viewport ID. So you can actually see, for now it still does nothing. But now, like for the moment, the status of our pipeline is draw 3 quad because we have 3 elements here. We have 2 texture here, and you draw a full screen quad. But because you're inside the viewport, it's a full screen quad inside the viewport. So now the idea is to say, no, I want to have the first picture drawn in viewport 0, the second one in viewport 2, and the third one in viewport 1. So we have all our pipeline set here. And like in the geometry shader, you can output position, you can get primitive ID, but you can also say, no, I want to say viewport ID, and semantic is so now on the output of the geometry shader, we say, okay, I want this primitive to go to this specific viewport. So now we have this error because it says we didn't set the viewport. So if we do output dot viewport ID, and I called it viewport ID, okay. And I'll just move this a little bit. And now you can see you can do routing from the shader itself, which is very useful compared to like you can really have full control where you're drawing things. So for example, I can say I draw this one, I draw this first slice here, I can reduce the size a bit. So yeah, with using the viewport, it's a very convenient way. For example, you can easily do like more complicated multi-screen installations, because you can just say, for example, route this to this projector, route this to this projector, and by setting your viewport, you can do it all in shader. So you can, as soon as you have it in shader, you can use it in instancing context as well, which is not really possible if you do it in with pure pipeline. At the renderer level, it's a bit too late. So here you can, you have pure dynamic routing. And yeah. Sorry? When you use viewport array, it's pixel space now, because it's just easier really. When we need multi-screen, I know my resolution. So if I'm on full HD, I just write the resolution instead of having to do this, well, simple math, but there's always a pen to add. So you just say, okay, I need pixel, I put pixels, that's it. So yeah, it's like every time you need to route content to a specific screen or place, whereas projector LED, it's very convenient to have it this way instead. So, okay, anyone done? Oh. VS input, it's just return input. Because I don't do any change in the vertex shader, so I don't have to do anything in there for now.
So is it pulling that system value from the geometry or from the shader? So like if we put that in stream out, would it work with the?
No, because as soon as you use stream out, you don't write to, you don't go to a pixel shader at all.
Yeah.
So that means the stream doesn't, you don't render to a render target. So as long as you don't render to a render target, it has no stream out has no concept of viewport or render target. Yeah. Okay, so now we're gonna do another one. So continue into geometry shader series. Okay, so this one is pretty simple and it's kinda almost already working. So we have this feature in DX11 which is called texture array. So who doesn't know what a texture array is? Okay, so like texture array is like, it's like, everyone knows what a volume texture is. So volume texture is just a 3D texture. Texture array is the same, but you can't sample on Z. So it's just like it has to be the same texture size, and it's not an array of texture. It's not like a spread of texture. It's like one texture which contains, like every slice is one texture, but you can't do inside slice sampling. So it's like very convenient. I'll show you in next examples later. But like one of the important thing is, for example, here I got a 32 by 32. So it's like 32 by 32 texture, and I say I got 32, it's called element count, so that's the number of slices here. So one thing which is, so we have two ways to draw into it in DX11. So if I say I have 4 slices, I can just say, for example, uniform scale, and just select. Okay. Oops, value. So you can either do it as projection. So how the pipeline will work is, like for each element, it will go through the layer and say this slice as render target. So that means for if you do it the standard way, you will not have access to you can't write to the whole array in one go. So you have to wait. You have to say this call is for this slice, and it's quite complicated. So now we're gonna use our geometry shader again, but now we're gonna go in the inspector. And normally it should be on by default, but what we have to double check is this is on. So it's called bind whole target. So that means instead of sending individual slice, it's gonna send you can access any of the array in one go. But you obviously have a problem. So we need to also be able to route. Now, like we have our pixel here. Like what we're gonna do, we're gonna add a little, just a dynamic buffer, color, and we just take 4 random color, HSL 05, 0.51. Oops. Okay, so we now have four colors, and yeah, like here you have already the reader, so I'll just explain it quickly. So you just have texture 2D array instead of texture 2D, and here when you do your sampling you have to use a float 3 like a volume, and you have like the XY coordinate of UV are the same for if you were doing standard texture, and the third one is the slice, but the slice is the whole number, so it's not like 0 to 1 value. It's like 0, 1, 2, 3, 4, 5. It's like really the real number. So this one allows you to see, for example, slice 1 has nothing, obviously, for now. Okay, so, well, this one you don't really need to change it for now. That's this one which is going to be more important. So, like, you have slice Z, 0, 1, 2, 3, and you can see for the moment 1, 2, 3 are black because we only write to the first slice. Like, if we bind the whole target and we don't specify in our shader where we're writing, by default it will take the first slice. But now what we want to say, we're just gonna draw one colored quad for each slice, basically. That's a very simple example, but It's in the inspector. Yeah. But it's normally on by default. It's just, if you want to write to it, you have to double check it's on. So, but by default, it should be on normally. Okay, so now we have our color buffer again. So structured buffer float for color buffer. Okay, so now what we need is in our pixel inputs, we need the color. So float for color. And we need to provide it here. And now, obviously, the return input doesn't work anymore. So we just have to do it. For the moment, we'll just return a white quad, but I'll explain why. Okay. And yeah, we obviously need to do it in the geometry shader as well. Color. Okay, so everyone here, more or less. Okay, so now the first thing we're gonna do is we're gonna say, okay, now we can connect the buffer, and we're gonna say we want to route this quad to a specific slice. So we just have int slice ID. And now we're writing, okay, I want to read slice 2. So for the moment I said I write only to slice number 2, to slice number 0. So now I'm gonna write to slice number 2. And we again need to control how it's done in the geometry shader. So we have another system value semantic, which is called SV render target array index, and we'll call it RT. So now by specifying this value, we're gonna say in our geometry shader, this primitive needs to go to this specific slice. So we say output.rt equals, for the moment, slice ID. And now you can see I'm writing to the correct slice instead. So like now, if I look on slice 1, there's nothing. If I look on slice, if I write to the correct slice now. Yeah, it's SV render target array index. I know it's a bit long, but
Can you show the float 3 UVs, how you
I'll show it after a bit, because it's like, for the moment it's more of writing. I can explain the reading after.
So where do we get the slice from?
Yeah. And now, like for the moment, we provide the slice ID as a parameter. And now we can also colorize it, so we can say output color equals color buffer slice ID. And return color, of course. So now we can finally use, for this slice, we say slice number 1 is supposed to be red. If we write to slice 2, we have the right color again. So we can use this GS here. I'll just put it back on. So to do all this dynamic routing, but you have one problem at the moment, is we're just writing to one slice at the same time. So that means every time we lose information, we don't write to the whole volume, so it's a bit wasteful. So what we can do is we can just spread this. So you just say, you just put an I spread from 1 to 4 and put it in slice ID. So now 0 should be green, 1 should be red, 2 should be. So now every slice is written, like we do 4 draw calls, every one with a slice ID here. So like for each draw call, we're gonna say this is, I want this squad to be in slice 0, this slice 1, and we can fetch the color buffer after. But now we can do it in a much easier way as well. So what we're gonna do is we're gonna get rid of slice ID. And like we're gonna say, okay, now instead of drawing 4 quads each time, we're just gonna use an instancer. And we need 4 instances. So now instead of having the slice ID here, in VS input, it's uint II sv instance ID. But no, we don't, because here it's, if you do it like this, it's like the storage is a constant buffer. So that means I can access this constant buffer anywhere. No, because I use the instance ID in vertex, I need to also pass it to GS. So you want. And so that's input dot II. So now we draw 4 quads in one call, so it's like the basic instance scenario. So instead of saying let's draw 4 quads and each one goes to a slice, we just say draw a batch of 4 quads and just deal with it in the shader. So if you have like only 4 slices, it's not very important. But if you have something like, if you start to do like large slice, writing like 200 slices, you have to do 200 draw calls, whereas you can just do everything in one. So it's always better to try to batch as much as possible.
Why we have a different semantic in the geometry shader than in the vertex shader?
Because this is SV, so SV is system value. You can sometimes use them as user, but I don't like it personally. Anything which starts with SV is system value, so it's supposed to be provided by the pipeline. So that means that's normally an auto-generated number. Like I call it instance ID after, because it means it's like when I look at it, it's not generated, it's up to me to give it.
Okay, so this is basically your definition now, and you call it instance ID.
Yeah, anything with SV is reserved, and any other name is like, you can put whatever you want. You actually, like people think semantic needs to be position, text code, or anything. Actually, you can put my cat if you want. That's not a problem. Yeah. if you want, you can use mycat, and as soon as it finds mycat as vertex output and AskJS output, that's okay. So you can put, it's just people tend to use naming convention like position, normals. But if you want to put anything you want, that's, as long as it's in input and output, that's no problem.
Maybe explain how you can write semantics, render semantics nodes.
Yeah, I'll explain, but I use it in some other parts anyway, so. So now we have this II here, so we just do output.ii equals input.ii. And output.art, we need to replace it by the input. Okay, just probably this way. Non, mais j'essaie de trouver un truc pour que tout le monde voit un peu tout en même temps en fait. On va faire comme ça.
Does texture array has to have always the same resolution in each slice?
Yeah, you can't. That's one part. It has to be same. You can't have different resolution per slice. Yes.
Can I ask about some example where you actually use this? Because, like, yeah, it's a pretty good feature, but I don't really know.
Well, for now I'm trying to show like a little not known feature, but after I got a bit more concrete examples later in the workshop.
So we will use it sometime.
Yes. Well, I use texture array. You have different use case, so it like you have the difference. You can like if you write to volume, you can't have a depth buffer at the same time. So you can use it as intermediate data structure. If you need a depth buffer, if you need depth test, you can use it as intermediate data structure and then copy to volume after. So you can. I use it for like texture array is really useful when you have instancing. Because if you have an array of texture, you can't do dynamic indexing. So for example, if you have like 10 quads in a batch and you want to say this quad I want texture 0, this quad texture 1, this quad texture 2, you can't do it with a spread of texture. With a texture array, it becomes really easy. Okay, anyone done? Pretty much? Okay.
Share all our finished shaders later, yeah.
Hmm?
You'll share all of the finished shaders.
Yeah, yeah, of course.
Yeah, maybe slow down a bit because most of it are used.
Can show the patch.
Yeah. Okay, it's just you have like a quad instancer with 4 instances and dynamic buffer with 4 colors, so each slice has a solid color.
Can you scroll to your pixel shader?
Yeah, it's like very complicated pixel shader.
Did you already change something? The texture array shader?
No, read, I'm not gonna change it.
Only seeing this white spot and the rest is black, so I think I was
Yeah, because you have the color equals 1 right thing. So it's color just right value when Each slice should be the right color. If you check the slice one now.
Did you change something in the read texture array?
No, I didn't change anything in there.
Something like a I think I missed that one.
Ah, no, it's already in there, so you should not have to change it. Okay, I'll just quickly explain also a bit why it's useful. So, like, one of the big problem, like for the moment, like if I do this read texture array here, I'll just show it, you don't need to patch it, so I'll just explain it quickly. So I'll just take a constant. And now let's say I want to use like 6 textures. So now I have this texture input and I have this texture bin size which should be around. Ah yeah, it's not gonna compile obviously. So it's texture 2D 0. Okay. So now I have this texture here, and I got the bin size which goes with it. So that means I can attach like 6 texture to one call. But actually, the way it works is like the problem is here. I can say texture 0, texture 1, texture 2. But if I do something like int slice, and I do texture slice, like pipeline will say no, sorry, I can't do that. So that means I can't, like I can use array of texture, but I can't dynamically select. I have to say this is number 1. I have to hard code it, so it's not very convenient. If you have a texture array, then you can see here I can dynamically say, okay, I want to use this texture now, I want to use this one. So you have all this dynamic indexing which is allowed. Because when you write array of texture, actually internally, okay, so when you write a texture 2D technically, so I'll just call it T1, well, there's a little missing part that is auto-provided for you if you want, but it's called register. So basically, when you have like for every texture or like what's called a shader view, so that includes buffers and texture, like it's assigned to a register slot. So if you don't specify it, the runtime allocates it dynamically for you, but you can also specify it. So like if you do this texture 2D here, you're not actually internally, the pipeline just does this. And T1, 2. So that means actually, even if you do an array of texture, every texture will be assigned a different slot. So that means you can't do dynamic indexing because textures are in a different slot, so the runtime doesn't know how to do that. Whereas if you use texture array, it uses only one slot. So the runtime knows how to access the data instead.
Are there still 8 slots?
You have 128 slots per stage in DX11. So you have 128 slots. So they don't need to be the same. So you can have like one for vertex. You can have different resources set to vertex, pixel, but
When I had this restriction to have eight textures,
no, it's 8 target. So it's 8 write texture, but read it's 128.
Can you quickly show how we now get like not colors but real texture data into our buffer?
Yeah. So actually, that's something I wanted to show later. So yeah, it's something I show in later part of the workshop. Okay, so now I'm just gonna show quickly the volume, but it's exactly the same, so we're gonna go through it very quickly. So actually, technically, with volume, it's pretty much exactly the same. It's like you have this quad, this volume, and you use the, well, actually the shader is not complete, but you can use the same one as texture array. It's pretty much exactly the same, except on the volume you have, like, the volume is bound as a compute shader output by default. So if you want to write to volume, you have to use this bind as target option. So that means you can access your volume in pixel shader. And it's exactly the same as texture array. You can access different, you can assign to slice. It's the same semantic, it's render target array. The only difference is you write a volume instead of writing a texture array.
When you say compute shader output, do you just mean like a 3D buffer?
Yeah, it's RW texture 3D.
Yeah.
So, well, it has, like, you can do it in compute quite easily. Like, if you write to volume in compute shader, I don't know if I have a CS around. No? Copy. No? I thought I had one. Okay. Oops. Okay, I'll just take this one. CS write volume. Actually, so you just have to set your thread to sensible, normally 8, and it's RW texture 3D. So yeah, if you do it in compute shader, it's more or less. Yeah, you need to specify the space as well. So that's normally if you want to write in volume with compute shaders, then you have this TID, which is voxel ID basically. So it's the voxel location. So you have TID .x, .y on this, so it's the exact voxel location. So it's quite, like in compute it's much more concise to write, but it's not always convenient. Sometimes you might need pixel shader for some reason. So in that case you still have to go to pipeline to write to volume. So it's the same as this instanced quad basically. So you just write one quad per slice. In geometry shader you route, and one important thing is, yeah, you can pass the slice ID. So you have your UV of your quad, and then you have the slice ID at the end. So you know the voxel location as well, so you can write to it in pixel shader instead. Okay, so we're done with the first part. which is a bit of geometry shader overview. Now we're gonna go into something which is, well, in some way very known, but I think by many 4V users not really known, if known at all, what's called the stencil. So who knows what the stencil buffer is? Okay, so that's, yeah, not so many. Okay, who knows what a depth buffer is? Okay, so that's good. Okay, so we're gonna check a bit what this stencil thing is about then. So when you have your renderer, here, you have the depth buffer format. And you can see you have different like choices. So you have D16 unorm, which you should never choose basically, unless you want really low quality depth. But it's, yeah, just generally don't use it. So you have D32 float, which is like a very common one, but the most common one is this 24S8. So that's normally the, so that means I use 24 bits for the depth data, and I use 8 bits for the stencil data. So if you use this, you have no stencil at all. If you use this one, then you have like this 8-bit of stencil.
So if you're not going to be using stencil, then you shouldn't choose that one, say?
You can, generally I just tend to use that one all the time. It's just like, it's good depth quality, and well, I use the stencil a lot anyway, so, but even if you don't, like, D24 is good compromise on quality, but you can use D32 float if you prefer, but then you might have to change quite a few things if you want to add stencil later, so it's a bit your call. So now we have this part which is a stencil, and now we're gonna want to obviously use it. So the first thing we're gonna do is, like, here we have this depth buffer output, but for now it contains only the depth view. So what we need to say is we want the stencil view. Okay, who knows what a view is actually? That's a very good question. Who knows what a view is in DX11? Okay, so I might want to explain that as well. Okay, so like when you create a resource in DX11, you first create a resource, but a resource is just a bulk of data, so the pipeline has absolutely no clue of what to do with it. It's just like a resource, so you say I want a texture this size, but so after what you do is you create a view which tells how to access that data. So that means, for example, you can say I create a texture, and you can, like, for example, when you want to render to a texture, you create one texture, and yet then you have to create a render target view which tells the pipeline this is how you can write to this texture. But then you have to create what's called the shader resource view, which tells this is how you read this texture once you finish to write to it. So that means the resource needs several views to be able to be attached in different places of the pipeline. So like by default, when we have the depth buffer here, I output the depth view because that's the most common. So here we just say, okay, use the same resource, but I want the stencil view instead. So basically stencil is just like, it's just this 8-bit flag. So it's just a value between 0 and 255. And that can be controlled by the pipeline. So the first thing is, what we're gonna do is we're gonna say, okay, let's see how to view what a stencil contains, because otherwise it's gonna be, so we have this stencil view now, and we're gonna attach it to view stencil. So it's a simple texture FX, which does literally nothing for now, but that's totally on purpose. So now we're gonna start. So we need to declare our stencil, which is a texture 2D with a twist. So, well, you can do it the NVIDIA way, which is not good. Or you can do it the proper way. So we'll do it the proper way, because if I do it the NVIDIA way, it will not work on any other card. So let's do it the way which works with every card. So we say like the stencil is value between 0 and 255. So that means it's not a float value anymore. So we have to say explicitly it's a uint 4. So we call it stencil texture. And it's going to be initial or previous, whichever is the same. Yeah, and I'll try not to make a typo. So now we have to type it as a uint, because it's, as I say, it's a value between 0 and 255. So it's not a normal, the pipeline doesn't know how to normalize that. So we have to, and now we can't use a sampler on the stencil either. So you're not allowed to use a sampler, but technically you don't need, there's no point of. So what we do, you see here in PS input, you have this SV position, and actually XY is the exact pixel precise location. So like UV is generally something you normalize 0 to 1 or any space which is convenient for your texture, but P is just the real 2D position. So what you can do instead is you're gonna say, so it's uint stencil equals, so it's stencil texture dot load. So we don't need a sampler, so we can just use load, just grab this pixel. So a unit for load is in pixel. So you just, for example, say get pixel 200, 200. And now we need the int 3. And now we need to get the pixel location. So as I said, we already have that data provided to us by the runtime, so we're gonna use it. So it's input.p.xy, not UV in this time. And like we have an int 3 because z is the MIP level, but here we have only 1, so we just say 0. And one important thing is .g. Like if you put .r, it works on NVIDIA, but it doesn't work on ATI and it doesn't work on Intel. Like I'll explain a little bit of it again. Why? It's because actually the R is the depth channel. So NVIDIA, like if you do .r, it will work on NVIDIA because it will say, oh, okay, well, it's a uint, so I know I want the stencil, so it kind of fixes it for you without telling you. But actually, if you do .r on any card which is strict, it will just sample the depth channel. So the stencil channel is the green channel, not the red channel. So now we have like this white renderer, which is supposed to be our stencil, which we don't have anything yet. So now we're just gonna say return stencil, but we're gonna do it by multiplier. We're just gonna multiply a value to it, because stencil is between 0 and 255, and if we return a readable texture, we need to provide a value between 0 and 1. So we're gonna need to downscale that value quite a lot. So now we save, and yeah, everyone's okay up to here. Okay, so now we have a black texture, which is normal, because we didn't write into our stencil yet, so we have just a 0. And yeah, one important thing is to specify the format here, because obviously you can't write to a stencil format, so we just specify the standard read format. So now we can view our stencil, but we have nothing in there yet. So what we're gonna do here, we're gonna say, okay, no, we have this bulk of box. And what I want to say is now every time a pixel gets written, I want to add 1 to the stencil. So we have depth stencil, render state here. And we have like a few stencils one. So stencil less is for later. The one we want to say is less read stencil increment. So that means use the depth buffer as less read write, which is a standard way we use depth buffer. But we also want to say every time a pixel gets written, we want to increment 1 to the stencil. So now if we attach that to our pipeline, then we can see suddenly we have something in stencil. And where is my multiplier? Here. So we just need to divide a little bit. So now we can, so like basically now what does it mean, how you can interpret this data? It's like every time a pixel gets written, it means you get a brighter value, because that means every time the more pixel written, the brighter the value. So actually the brighter the value, the worse is your pipeline setup. So if you want to, like, if what you want is to technically minimize, like for example here, you have a very bad pipeline setup. Here you have a pretty good pipeline setup because you write less. So you maximize your depths. Like, who knows what early depth is? Okay, I might go through that as well. So when you write a primitive, like you have the vertex, well, domain any tessellation stage, and you have the pixel stage, and you have this depth. So like when you reach the pixel shader, the depth of the pixel is already known. So the runtime already knows the depth of the pixel. So you have this feature from graphics card which is called early depth. So that means it's gonna say, okay, I'm just gonna check the depth buffer value, and if my pixel is behind the current one, I'm not gonna even bother to call the pixel shader. So that means you don't even go into your pixel shader at all. So if you have like very complex pixel shadings, it's really important to try to sort out to have your pixel called as less as possible. That's how people do depth pre-pass. I'll show an example after. So like here for the moment, it's like so it's very simple. So like you have this less read increment, and now we're gonna say, let's add a sphere. It's just to show a bit different patterns of usage. So I'll just do a friendly normals again. Sphere. Yes. No. This. Okay, and I'm gonna increase radius, and you can actually see here it's not it's written in my depth, obviously. If I do a preview. Here, and we can like change the near a bit. Okay, so you can see it's written in the depth, but it's not written in the stencil, because obviously we didn't attach the state. But what we can also do, we can also do something like depth stencil, and let's say we're gonna need the advanced version. Okay, so there's gonna be quite a few things in this. So what we're gonna want to do now is I just want to say, okay, everywhere my sphere is, I want to reset the stencil to 0. So like we should have a black sphere in the stencil view. So first we need comparison is for depth, so we use less as usual. depth write mask is how you want to write. So we want to write to depth buffer, so we set to all. Then enable depth, well, obviously we want to enable depth. Enable stencil, yes, we want to do this as well. Stencil read mask, we leave to 255, I'll explain that later. Stencil write mask, same. So backface comparison, we need always. Depth fail up, we can keep. We just need to use both comparison to always. So I'll just put the pins that are needed to change. And now you have this thing which is called pass operation here. And actually when we do the increment, actually this one is just a preset for this advanced state basically. So we just say every time a pixel is written, we can control how the stencil is done. So we can just say keep the current value, or we can say, for example, set back to 0, which is the reset here. Or we can say replace, that's something I'll explain later. We can increment, decrement, invert the value, or you have like the increment, decrement, and clump. So that means like if you reach the maximum value with increment only, it will go back to 0. So it's something you generally never use, basically. You generally so, well, what is quite useful in that case, it's also like so you have this information here about how many times a pixel has been written. But that's also very valuable information, which is also, has a pixel been written at all? Because anything which is 0 means this pixel has never been written. So that's a very valuable information for your scene and for the next step. So everyone kind of understand, or a question? Anyone got question still? Or? Huh?
What's the initial semantic?
The default state, you mean?
No, the initial.
It's the same as initial is always the texture input. So it means take the texture input from this.
But so why is it needed then?
It's just because otherwise it will create a pin. So it's just to say use the texture in instead.
This is for the texture effects.
Yeah. Okay, so now so stencil can hold this very useful information, but the important part is, well, we can also use it for a bit more advanced techniques. Because for the moment it's only writing to something, so you could write to extra render targets and have the same information. So you could say, do an additive blending on a small extra texture in my pixel shader and you'll have the exact same result. But now we're gonna have the important part about stencil. So it's called stencil test. Okay, so here. So here you can see we have a, well, totally stupid invert post-processor. So nothing really fancy at all. But now we're gonna want to do something. We want to say now, I don't want to invert the background. I just want to invert the object. Because I don't want this white background. So now I said when you do this So you have this scene, you're rendering to this stencil enabled place, and you have this stencil invert basic here, which for the moment just inverts the color. But now what I want is I only want to invert the cubes. I don't want to invert the background. So you've seen in the previous sample that we know in the stencil have this information. We know if a pixel has been, so anything which is background, the stencil will be 0. Anything which is foreground, the stencil will be something else than 0. So now we can like also say, okay, I want to apply this post-processing only to this, to the pixel which got written. So now we need to set our stencil state again. So depth stencil increment. We need our stencil view again. Just it's the same state as in the previous sample. So just every time a pixel gets written, increments the stencil to 1. So now we in the invert here. So what we need to do is to add texture to the uint for stencil texture. So that's gonna create our pin. Now we need to load our stencil again, so it's exactly the same code as before. We're gonna rewrite it. Uint stencil equals stencil texture dot load int 3 p dot xy 0 and dot g. So now, well, it's like the post-processing is pretty obvious. We just say well, you can do it with the if statement, or you can use the short version. So I'll use the short version. So you say if stencil is more than 0, then you want 1 minus color. If stencil is 0, you just want color. So if I save, and now you can see I only inverted the pixels that got written. I didn't inverted the sky. Because I use it for, well, previous and initial are the same in that case. They're only relevant in multipass scenarios. So previous is take the previous texture, but because I have only one pass, it will take the input. On the first pass, it takes the input. Initial means always takes the input.
Explain how it interacts with MSAA.
I'll explain later that because. So that's in the next patches. Okay, so now, well, we have this invert working. So everyone got this simple invert yet? Okay, I'll just put that back in. And I'll try to move this a bit so people can see things. Sorry? Do you have the, did you set the state as well? You need to use stencil view also and attach Okay, everyone here, pretty much? Okay, so now, well, we've done this invert shader, but it's completely wasteful, and it's really a bad way to do it. Because what we've done for the moment, if we look, we actually use the stencil in a very bad way, but it's good for visualization. Now, what we're gonna check is we're gonna check this query, which is called occlusion, to explain what we've done badly. So we have 124 by 768, which is the number of pixels, which is exactly how many we processed this amount of pixels, which is the same resolution as the texture. So that means we've processed like almost 1 million pixels for inverting only a small part of the scene. For this, we have one binary condition, and we have 2 texture lookup. So we've done also like 1.5 million texture lookup and 1.5 million conditional pass. So that's not too good. So now that's why the stencil starts to be interesting, is you can use it for write, but you can use it for pixel rejection as well. So now we have the same here, stencil invert text, and we're gonna do it like by using the stencil properly. So actually, this is the same thing, but we only have the input texture and we invert the texture. So that's the way we should do it. So we don't have any conditional, we don't check the stencil, and that's pretty much everything we need. Just try not to. So now, here you can see I have a render state because I'm gonna obviously need it. And I have a renderer. So what I want to do now, I want to say, like for the moment I've gone through the pixel shader for every single pixel. Now what I want to do is I want to reuse the stencil to say, if a pixel has not been written, don't go to the pixel shader. Because there's no point of doing it. I don't want you to do anything. So instead of doing a condition in the pixel shader, I can just say, just don't go through it. So we're gonna do it in our renderer. We're gonna have to change little something. So you have this depth buffer mode here. And you have this option which is called read only. So you just set to read only here. And now you have this depth buffer output, and it creates a depth buffer input.
So when you put read only, that's when you get the depth buffer input?
Yes, that will create you a depth buffer input pin. Because now you don't want to write to the buffer, you want to read to an existing buffer.
Can you show that part again?
Okay.
Where you take it?
So depth buffer mode, you have non-standard is the way you use normally for writing, and read only will create input pin instead. So now you have this depth buffer pin that you connect to the depth buffer out.
Basically, that part is like initialized with that.
That means you provide a depth buffer and a stencil buffer in our case, which already contains data.
Yeah.
But that means, but you can't write to it. You can only read it. Well, yeah. So now we have our render state here, we have our quad, and we have a stencil which is also set in the pipeline. So now we're gonna say we have our depth stencil state, advanced. So we're gonna go through the pins again. So comparison is the depth, so we can leave it to always, because we don't want to use the depth buffer. We want to use the stencil only, so we can leave to always. Depth right mask 0, that's fine. Enable depth 0. Enable stencil needs to be set to 1. And suddenly you can see my texture disappeared as well. You can see I have a black picture. Because now the stencil, I'm doing a test, so nothing goes in the pixel shader anymore. So you have stencil read mask, which needs to stay here. Stencil write mask, you should set it to 0, but because it's read only, you don't really care in that case. Now you have back face comparison. That's the important part. And front face comparison. So now you're gonna have to, like here it's set to never, so that means never go to the pixel shader, which is not very useful. We can use the same comparison function for each. So now if you do less equal, like the best one is you just use not equal. Like the stencil, the reference is 0. So if you say, if the stencil is not 0, go in the pixel shader. If the stencil is 0, don't go in the pixel shader. That's basically what you mean by using the comparison function. So now if you look on occlusion query, yeah, you can see you've processed only 1/8 of the pixels. So instead of doing 2 lookups, like one more write, pixel shader call, like doing it 76432, you've done it only 100,000 for exactly the same result. So that's pretty, well, if you start to do, like here it's a stupid invert function, but if you start to say, okay, I'm using now 20 point lights, you might start to want to remove as much as possible. Like it's very commonly used in shading, because if you want to apply a light to, instead of a post-processing like invert, you apply a light. Light are quite expensive. So if your pixel did not get written, there's no point of having to iterate 20 lights to it. So it's quite a massive gain for, it's like the basic of deferred rendering. You use stencil for this. So you can see, yeah, if you check the query, like if I really zoomed out, I only really process very little amount of pixel. I only process the relevant pixels that I need. So that's what makes the stencil really useful compared to like just a simple target, because you also have this option of using it for rejection, a bit like a depth, but a bit more flexible. So it's really useful for optimizing. You can set different values to it. No, because you can't do alpha test in DX11 anymore. Well, you need to do it in shader. So you could do an alpha test, but that will be the exact same thing as doing it with the stencil here. So that would be the same. You'd have to look up for alpha, reject if it's not, so you will end up in the same situation. Whereas in this case, you can just completely reject it before to apply anything.
And if you do like something like one lookup and then you just discard, like
if you discard, you don't write to depth and you don't write to stencil.
but performance-wise, is it like somewhere in the middle between these two, or just do like one texture lookup?
I'll explain discard later. You mean discard here? Well, you could have problem because in some case discard would work, but in some case it would not. Like in that case, like for example, you have like it's a very simple example. So in that case it works, but yeah, I'll show discard in another example later.
Is there any way to use this with like a texture effects chain, or do we kind of lose the?
I think if it's not broken, yes. So I'll have to test it. I know you can bind depths, but I remember there was some bit weird things with it, so I have to recheck that. But yeah, normally it's possible to also bind the depth input to a TFX chain, but I don't know if the states are bound properly. I'll have to double check that. I can't reply right now. But normally you should be able to do it in texture effects. So if it's not working, it's my fault. Okay, so next part, like now we've seen we use the stencil like in a pretty easy way. Now we're gonna try to make a bit more complex usage of it. So now what we're gonna want to do is we have these boxes here and we have this sphere here. Very simple example. So now what we want to do is I want to say now I want to invert the boxes, but I want to apply a blur on the sphere. And obviously I don't want to do if statement and I want to use the pipeline because blur is already a more expensive operation. So that's when you, like for an invert, you will probably see almost no difference, but a blur starts to become a bit heavier. So now we gotta say, so we have our stencil invert, which I probably broke. Yeah. Ah, that's okay, and here. And we have a small blur here. So how we gonna do that? Very good question. So what you can think of the stencil, it can be a value between 0 to 255, but it can also be what's called a bit field. Do you know who knows what a bit field is? Okay, so if you think about a 0 to 255 value, you have to think about it as, well, you know, everyone knows binary. So if you think of a value between 0 and 255, it can be 8 flags. Because it's each bit, you can set bits as 0, 1 only. So instead of interpreting your stencil as a number, you're going to interpret it as different bits. So that means we first need to... So what we're going to do is instead of... we can't use increment anymore because I want to be very specific of use box, use sphere. So I can't use increment anymore. And I can't really say, okay, use this value or not. So we have two ways to do it. So first we have, so we're gonna do it the non-bit field way as to start, so maybe to make it a bit easy. So we have this node called stencil reference. That we need to attach here. And we're gonna need to attach the stencil reference here as well. So it's a bit, in that case, it's a bit strange, but you're gonna need to attach your state to the group. So you have this reference value here, which is 0, and this reference value here, which is 0. So obviously we want to say, to know if our stencil has drawn a box or if our stencil has drawn a sphere. So we need a different reference value. And obviously we don't want 0 because 0 means nothing has been written. So we're gonna say 1 for box and 2 for spheres. And now we need to set our stencil advanced state properly. So comparison is less because we want to use depth buffer. Depth right mask is always all because we still want to have depth. Enable depth, well, on. Enable stencil obvious. Stencil next. So you have the comparison function, which we do always. because here we don't want to test anything. So we want to, the stencil is, we want to write to the stencil. We don't want to use it for testing. And now we have the pass operation, which is back and front, and we use replace. So let's summarize it a bit. So now we have our standard depth setup, so less for depth test, write all the depth part, enable depth, enable stencil. We don't want to test anything, so every element should pass the stencil test. And we want to say, each time a pixel gets written, you want to replace by, replace means replace by the reference value, basically. So that means now every box will write 1, and every sphere will write 2.
So the order important in the group?
In that case, yeah, you need to set the depth stencil before the reference.
And the order of the 2 layers in the group?
No, the order of the layer is not important in that case.
So is that then the order of the stencil reference? Well, sorry, the index you go see.
Yeah, that means like if I put like, I can put anything between 0 and 255. So if I put 100 here, it means like anything which is.
Shall we use powers of 2 then?
Well,
We're not using bits yet.
it depends. If you want to use bit field, you will not use power of 2 actually. I'll explain that later.
But does it depth test first, and then it's
I don't know, I forgot in which order it's done. It probably depends on the card. It's gonna do depth and stencil at some point. But I don't know the card in which order it does depth or stencil text.
yeah, but it's different because then otherwise like all the visible thing could be replaced.
No, because you need to pass both depth and stencil to get written. If any of depth or stencil fails, your pixel don't go in the pixel shader. So it has to be both conditions satisfied. So that means it can even be done in parallel. They can do depth test and stencil test in parallel and then say, do the Boolean at the end. Okay, so now we have this stencil invert. So I've put 1 on, well, let's put 50 just for trying it. And now we're gonna need to say, well, we need to add a group again, because we're gonna want to say apply the invert on the boxes. And well, we obviously need to connect the input texture. So for the moment, we apply the invert everywhere again. So we have to do our depth test again. So we enable stencil again, and we need to do the front face comparison and back face comparison, both two. In that case, we want equal, and we need a stencil reference. Which in our case is 1. So now we just said, okay, don't use depth as before, and we just want to say if your pixel value is this specific value, then you pass the test. So that means now
We don't need to do that before
to do what? Sorry.
the test. We don't need to do that before the shader.
The test you can do it anytime.
But it's not.
No, you can't do it before the shader. No, you have to do it in the layer. For the moment. So now this one is equal, so you just set stencil reference, and this one has to be 50. So you just say my stencil reference is 50, and I connect to my layer here. So now basically you didn't even have to do any shader or coding to do all this rejection, which is what's pretty cool. Also, like the pipeline, you can achieve a lot of different things using pipeline only, so you don't always have to think of doing all these complicated things in shaders. Like the pipeline helps you a lot for different purpose, so it's quite useful to know how to just do it. Like here, you would have had to do a lot of conditional things in shader, which would have been quite complex. Instead here, your shaders are super simple. You can reuse them for if you want to do a full screen blur, you can use the same shader and don't have the test at all. So it also helps to have code simpler as well.
How does it cope with the edges of an object with a blur?
Well, for here, I just, it crops the edges. Yeah. It's like a very stupid example. I didn't try to do anything extreme complex.
But there wouldn't be any way of extending out from the stencil?
You could, but that's not so simple. Okay, so yeah, actually, just by using simple states, you can also achieve some complex operations. So that's also one of the nice features you can have in DX. You'll not always have to go crazy in pixel or vertex shader. You can also do really simple things and also make it faster.
So were you wrong to say that DirectX11 is very shader-centric?
No, it's still shader-centric, but the pipeline helps you to make it clean as well. So, but the shader doesn't exist without the pipeline. If you don't set your pipeline, the shader doesn't know what to do. So it's always the pipeline is here to help you to make your shaders better. Okay, so now we've used it as raw value, which is useful, but it's not always useful. So now what we yeah, maybe the best thing to do is save as, because I'm gonna destroy it to redo things again. So yeah, it's better to just save as well, 2. Okay. So now we're gonna change a bit the way we are doing it. Now I'm gonna set a reference value to 255 in both places. So now we have our stencil reference to 255. So that means I always want to write the maximum value. But here I still want to achieve the same operation as before. But now instead of assigning an individual number, I assign the same number. So that's when, instead of using it as number, we're gonna start to use it as bit field. So now we need to disconnect, and we're gonna need a separate render state for each part. So now we're actually gonna really use it as bit field, because before we just put a random number, but if you put any number, that means you can't use it as flags. So that means you can't have this condition. For example, I want to know which object has passed this test and this value. So we need to use bit field in that case. So like that, a common usage I do is, for example, I use it for bloom and fog. So I can say, I use 1 bit to say you're not part of the fog, and 1 bit to say you are part of the bloom, whatever your brightness. So if you use arbitrary numbers, you can't do that. So you have to use bit field for it. Oops. So depth stencil state advanced again. Keep the same. So you're gonna get used to set comparison less, all enable depths, same as before. Now we're just gonna copy paste so we can use it in each. So it's like comparison less, depth right mask all, enable depth 1. That's like the 3 things you always need for a standard 3D scene. You can have it as a, it's gonna become robotic at some point. Here, less, all, and 1. That's like the standard simple depth. So now we enable our stencil again, of course. And now so we have to set our comparison function again, which is always, because we don't want to do any stencil test here, we want to write. And now we want to say the pass operation to replace again. And I'll just say to 1 here in the min. And here we're writing 255 instead. So that means we're writing this, I put increment on clump, so it should be replace. So now we are writing 255 on each part. But now what we have here is a stencil right mask. So we're gonna say how we want to write the value. So it's really a bit field. So it's like the binary value. So if you want to say, for example, I want to write on, like, if you think of a bit field, I have a very easy way to do it. No, I want it the other way around. 1, 8, here. Yeah, you can consider it as 8 toggle. So that's basically what the bit field is. So actually, since we need to convert this toggle here into a value, we're just gonna do it like that. So it's I 1 to 8, and it should be po. And and plus and no, it's not working. It's, yeah, okay. It's power of 2, so it's 2 here. And 0 to 8. And, okay, well, just the easy way, multiply. Okay, so now we have our little bit field setup. So now you should have the right value. So now what we're gonna, as I said, like this, if you have everything on, you see you have the value 255, which is like the, so because it's a byte, so you can cover the whole range, but now you can define, when you set arbitrary value, now you can set Boolean flags instead. So you can say, okay, yes or no, and you have 8 of those. So let's say now I want to say, for example, if you are a box, I want you to go in the 3rd slot. Well, you can choose any slot, it doesn't really matter, but you just say, like I want box to go to that slot, so that means box will have a value of 4. So that means your stencil reference here will be 4. And if you say, I want my sphere to be in that slot, that's 8. So that means the stencil reference will be 8. So that means here you have this right mask that you set to 4, and that right mask that you set to 8. So now you're writing the maximum value, but because you have this right mask, you're writing 255, but only where the flag is on. If the flag is not on, it will not write the data. So that means you can use Boolean operations for it. So you can, if you want to do a bit of material for post-processing, it's a very easy way to say, just disable me for the whole fog and enable me for the bloom, for example. Or I don't want to go into the shading because I'm already shaded. So I don't apply any light on me. So you have 8 choices to decide operations for you. And because you have the test, you also obviously maximize your pixel shader usage by not going there. Because otherwise you'd have to do the test for fog, you'd have to do the test for light, you'd have to do the bloom pass. So here you just can easily early reject anything. So hope that makes a bit of sense. Yeah?
When you've got multiple flags on like that, will that stencil reference value still work as it is, or does that need to be changed?
Well, in that case, because I use it as bit field, I always set the reference value to the maximum,
Yeah.
and I change the right mask instead.
But the actual value written should be the same, right?
Hmm?
The
The written value should be the same, but the only difference is instead of using, I never change my reference value again. I only change the right mask instead. It's 2 different ways to do it, but it's a bit easier to interpret as bit field if you use right mask, but you could use reference value on 2. No, actually, it's not true. No, actually, I'm wrong. Sorry, it's not the same. Because if you use the stencil reference and set to 10, like you still preserve the write. So that means if something is here before, it will stay because you don't write to it. So like if you use the write mask, you don't overwrite. If you use the reference, you overwrite everything. Okay, I think I'm done with stencil now. What's the time? So half an hour, just to choose which sample I'm gonna get. Well, actually, I'm gonna finish by another stencil again. So at least we are more or less. No, it's not stencil. This one actually. Not sure which one I will go. I don't want to go to a too long one.
No, of course.
Yeah, maybe we can do this one.
Maybe we can ask. We can see if they have questions.
Okay, do you have questions so far, maybe?
It's not order independent because if I move the camera, this is wrong.
Okay. Okay, so. Huh?
I didn't manage it to combine it. Let's say the spheres should be inverted and blurred.
No, yeah, you need to, in that case, you need to do a different test for it. So you will need to do a different, something I can show you after. But you need to combine both, and you need to change the test in some place to do both as well.
So the second stencil
Yeah.
should be different.
Yeah. Okay, now we're gonna show a little other feature. So we're gonna have this thing which is called read-only depth. So we always had this problem with, like, let's say you rendered your scene, you did a lot of nice post-processing, and now you need to add, so now you have this texture here, and you want to draw a sphere with alpha on top. So you have drawn all your solid object, which is a standard deferred pipeline. You draw your solid object, you apply your shading, you apply your depth of field, and then you start to render transparent elements. So the first thing you need to do is, we have this depth buffer here. So we have our texture here. We have here what I want to do, I said I want to draw an alpha sphere. So what I will do first is I'll just do a constant here. And we need to draw the texture itself. So no depth. So we just draw our texture first, but here we have the sphere, that's normal, don't worry. Maybe if I put a quad, that will also help. And eventually two. And here we have a camera bound, so we need to have this within projection. So now what I want to do is just to draw a bulk of 3D sphere on top. But I want them with alpha, so that means if the sphere is behind the solid object, I should not see it. If it's in front, I should see it with transparency. So we have the same concept of depth buffer mode, which we're gonna reuse again as read-only. So we can do that more or less only by state, basically. That's now very simple. So that's the basic of it. So now we are on blend. So our sphere is, of course, dealing with alpha test using the same camera. So if we move it a bit. So yeah, well, we can see it's maybe sphere is maybe not the best one. This. And we need to bind our depth buffer. That's probably why, actually. So yeah, now we reattached our depth buffer, so we can see like it only passed the test. So that means we can reassign depth after applying, like here we can apply post-processing to our solid scene, and then we can start to draw alpha objects after, but we still need to have the depth information. But now you're gonna see something which I really don't like. As you can see like this really sharp edges with the alpha shape. Like you can see these very clear, very not good looking edges here. So one thing which is kinda cool was you have read-only depth. is you can use it as input and output. So that means you can use it for the depth test to just reject transparent pixels behind, but you can also access the depth texture in your shader to have depth information from your scene. So what we're gonna try to do is we're gonna say, okay, if you're very close to a solid object, try to decrease the alpha a bit more. So like it looks a bit more soft, because here you have this really hard edge between alpha and non-alpha. So we're gonna try to make it a bit softer. So first we have this post alpha here. So you already have this soft power on soft scale. So you do texture 2D. Technically it should be float, so it's depth texture. So now you can connect your depth buffer also as shader input.
Can you show that step again, please?
Yeah, you write texture 2D depth. Just simple texture input. And then you can connect your depth buffer. So your depth buffer is connected for depth rejection in the as render state, and also as shader input. But that's only because your depth is read only that it's allowed. Or if the depth is like read-write, you can't access it as input because your data is not relevant. That's just like. So now what we need to do is we have the same texture, so we need to say now we have the depth actually of our object here, which is input.z, and now we need to know the position of the solid object next to the pixel. So we're gonna do float d equals, so it's depth texture dot load. So int 3 input dot pos dot xy 0. So now we're just gonna load the depth pixel, which is next. We can do more complicated, but I'll keep it a bit simple.
Would we need to change something on this line if we also have stencil in this depth texture?
No, because I using the by default I use the depth view.
Ah, okay.
So stencil, if you need the stencil, you need to use stencil view from depth buffer. It's, as I said, like you have these different views, so it's the same resource, but you have to assign a different view to interpret it.
So the default one is already set.
Default, I take it as depth because it's the most common one we use in general. But it doesn't cost you any memory or resource to use stencil view, because it's just a way to interpret data. So now we need to evaluate the projective depth of our pixel, so that's basically, if we're on pixel here, that's the depth of the sphere which is behind. The D doesn't represent the depth of my transparent box, it represents the depth of the element behind, or no element, if there's nothing behind. So now we need to evaluate the depth of my alpha box. So we can do it in two ways. So we can either take, because the depth reconverts the depth from depth buffer in view space, or we can like convert the view space depth of our sphere into same format as depth buffer. So we're gonna do it the second way. So the box, I'll just name it stupidly. So it's input.p pos.z divided by input.pos.w. It's just, I'll just put it next to the pixel, so at least it's easy to read. It's a bit of optimizing space. So now we have the distance of our element behind and the distance of our box, which is a lot of pretty cool and useful information. Because now we can start to apply different things. We can apply different parts. So for example, we're just gonna visualize this depth difference. So float diff equals apps d minus d box, which is normally I should not even have to do that, but because I know from the depth test already. So and do we need the W actually? Yes, we do. Okay, so now we and it's something not right here for now. Hmm?
You're returning the difference.
Yeah, but that's why it's not. Ah, yeah, but it's projective, so it's better to do that in view space actually. Yeah, it's not too good. So let's do it in view space instead. Oops. Okay, so we need to do it in view. So now we have to say float 3 pos view position view and output dot pos view equals mul p mul t w t v. Okay, so now we have our view space. That's going to be a bit easier to reason about technically. And do I have a linear depth? Yes. Yep. Yeah, I just can't be bothered to redo that one all the time, so I just grab it. Okay, so we need the projection and we need. Okay, so what we do is we sample the depth texture. Well, we load the depth texture for the pixel. Then the depth texture is in 0 to 1 range. So what we do is we do the linear, we convert it back to linear. So we reapply the near plane on far plane, so we have a real view space value, because for the moment we have a value which is not really usable. So it's better to work in linear scale. Here it's like log scale, so it's not very convenient. So now we need to change the box because it's just input dot post view dot z. Actually, we can use that. That should be linear too. And now we don't see too much. But yeah, now you can start to see like I exaggerate the value a lot, but you can start to see, you see now the visualization, it becomes darker. Like if I'm close to a solid object, I have a very dark value here. So now I can use that information, which is the distance between my pixel and the depth, to make the alpha lower.
Oh yeah, but you're not using LD.
Oh yeah,
That's why.
that's also why. Well, we can do it that way also actually, so it always depends which space we want to use. So now we have these two elements, soft power and soft scale, so we're just gonna put this parameter. So it's soft power multiplied by soft scale. Okay, so I'll explain a bit while people are writing to summarize a little bit. So the idea is we get the depth texture pixel for solid, we get the depth of our object, we compute the difference between each of them. So that means if our object is very close, what we want to do is reduce the alpha a bit more. So you have almost zero alpha. We want to remove those borders, basically. So the closer you are from a solid object, the lower your alpha should be. That's the basic concept. Ah, this one. I'll try to shrink code a bit. 1 second. So we can pack a bit more.
Just curious about, so you can explain later about Stencil Buffer and stuff like that?
I can explain it just after.
Yeah, cool.
Yeah. Sorry?
There was this new command line flexible with like DirectX11 mode and video.
Yeah.
And it's always active apparently. Like my computer always starts in video mode, which is not good because it's super loud.
Yeah, but you know if you set your to automatic, when you start 4V, it will start on NVIDIA. It's only if you're already on NVIDIA mode, it will start on NVIDIA whatsoever. Then if you don't put any mod, it will take the first card, so it will be integrated graphics. Okay, you
always starts with NVIDIA now.
Okay, that's something you'll have to check around. Okay. Okay, so now we have this soft power and soft scale values here. So we need to try to find a bit of a sensible preset for it, just like for tweaking. So actually when it's quite dark, it means it's quite good. So that means anything which is white will be the standard alpha, and then we're gonna multiply this. This is gonna be our alpha mask, basically. So for now we have it as a difference, but now what we do is instead we do col.a multiplied again by this, and we return our color. Ooh. Ah, yeah, oops. What very important thing to add. If you want to multiply, you need to saturate. So saturate is a clump between 0 and 1. Because if your value distance is more than 1, you don't want to increase the alpha, you only want to reduce it when it's very close. So we have to use saturate for it. And now it makes more sense. So yeah, now we can see by changing the power and scale parameter, now we can start to have a bit more. We can see our alpha is not like before we had this very raw edge. Now we can start to have a bit more interesting and pleasing looking for alpha. So yeah, you're not limited to alpha as well, because now you have this really useful information. One thing which is kind of cool, you can also use the distance to, for example, blur the texture behind, so that can give you some kind of glass effect. Like if you use, instead of using the depth to change the alpha of your object, you can use the depth to blur the background. So the more distance you have, the more you blur the background. So you have this kind of glossy, you can do some bit glossy material, bit more grainy. So you have a lot of different possibilities with that information. Okay, I think that's for the morning.
That from texture is logarithmic, right? Space.
Yes. That's why I use this power function here, because normally I should use linear space, but I mean, best is you normally should use linear space, but for the example, it's. Okay, I have to think how I organize the afternoon.
Could you show the input pins, because I don't have the result of this, and I don't know what.
It's soft power and soft scale.
No, there's no the input pins in the patch ending. Maybe.
In which patch, sorry?
Patch itself. So you need some texture here.
Yes, you need the depth texture, yeah.
From here?
Yes.
Okay, so then.
This is here
Yeah, within progression, that looks correct. Check inside first. Just try to return 1. Very call again. Okay, go back. Power is really high, so it should be between. Yeah, there you go. Well, let's call it an artistic effect. No, you're checking your post. probably have wrong resolution. Yeah, it's like one is double scale like this. Yes, fine. I'm using load, I'm just loading the pixel instead. Ah, yes, it's right. Yeah, that's the one. Yeah, I think so. Yes. Largely, I think we're not. Yeah. Yeah. Well. Okay, so I think that's well. There's still some MS. I'm gonna scrap this one because it doesn't make sense. I'll go through this one and this one.
And then tesselation.
And this one will take. This one is cool.
Maybe.
This one is cool for after lunch because it's easy as well. And I'll use this one because this one will take a while actually. This one will be long.
Yeah.
So maybe I do this and then do MSAA and see how it goes. It's probably easier to just do it that way. So I will do bonding and heat will take some time because there's a lot of different places and things to do in there. It's already a bit larger compared to the rest. Okay, we're gonna, well, any question? Otherwise we're gonna have some lunch.